Introspecting via the terminal is good when you quickly want to examine ROS nodes or programs. Like ROS1, ROS2 offers a GUI tool for interacting with ROS in a user-friendly way. This tool is called RQt, spelled as RQT. To use RQt, open the terminal and run the TurtleSim node. ROS2, run, the name of the package, the name of the node you want to run. Fine, so the next thing is to run the avoid wall node to make the turtle move around. Before running the avoid wall node, let's source the workspace. And then we can run the node. Remember, the avoid wall node is under the turtle control package. Beautiful. Now let's quickly introspect the pose of the turtle. To introspect the pose of the turtle, just run ROS2 topic, and the topic responsible for the pose of the turtle is the turtle1. Okay, so I'm going to use the echo, and then turtle1 / pose. Now we can see the position and orientation of the turtle as it moves around. Okay, now we've run the introspection. We've done the introspection via the terminal. So to do the introspection with RQt, which is, stop this one right now, and then type RQT for RQt. So if you're running RQt for the first time, it's going to show an empty space like this. But if you've run it before, it's going to show you where you stopped the other time. Okay, so there are a bunch of tools in RQt. Most of them are called plugins. So we want to see like the importance of RQt and how to use the plugins it provides. The first thing we want to do here is to use the topics and the topic monitor. So the topic monitor basically shows you all the topics, and then it can give you information about each of the topic in the topic monitor. Okay, so to see the pose, just as we did on the terminal, you just click on the drop down, and then it's going to show you every information inside the pose, and then you check the box. So immediately you check the box and start running, and then you can see the pose here running at this frequency. You can do the same thing for the CM_devel if you want to see what's inside the CM_devel. We have the linear and then the angular velocity. You can then check, and it's going to show you the velocity. So basically, the turtle is moving 2.0 meters per second on the linear x direction. And then the rate at which these messages have been published or have been shown here is at about 100 Hertz. All right, so let's examine another important thing in RQt called the service color. Service color can be seen under the services. Remember, we talked about services in a previous lesson. Services are based on a call and response action. So when you call a service, you get a response. All right, so you can see that the turtle has been giving us some kind of white lines or white markers all over the turtle simulator. So what we're going to do now is to call a service that clears the white marker. So to do that, you click on the service, and then you choose the clear. So these are the list of services currently running. So you choose the clear, and then you can then call the service with the call button by the side. Immediately we call the clear service. You can see there is a response which clears the white marker. You can do that again, and then it's going to clear the white marker. So let's just do one more thing. This time, we're going to spawn another turtle at a desired location. So you can put in any location you want. So I'm just going to put 3, and then I'm going to put 4 here. So you can decide to also give the theta, which will show you where the robot is going to face when it's been spawned. And also you can give your turtle a name, but I'm just going to leave it default like this. So if you don't pass any parameter as a string, the turtle sim is going to just, assign a name called turtle2, because the first one is called turtle1. By default, it's going to assign turtle2. So let's call this service, and then a turtle should be spawned at a location 3, y in the X and Y axis respectively. All right, so I just called it, and then this is it. So you can see the value now is called turtle2. So that's the name of the turtle. So that's not all. There are a whole bunch of interesting things that you can do with ArcQt. So let's examine another important thing, another important visualizer plugin called the ROS node graph. Okay, so the node graph is under introspection, and then you can choose the node graph. So let's close the service caller so we can have the node graph. The node graph is very, very important when you're trying to debug your ROS programs. You can see the node graph has a kind of GUI and some oval shapes and some lines that shows you what is a node and what's a topic. So you can see the marks, the text inside the oval shape, they are called the nodes, while these ones on the lines are called the other topics. So basically what this program is telling us is that the avoid wall node is actually publishing command velocity to TurtleSim, while the TurtleSim or the avoid wall node subscribes to the pose of the TurtleSim. So the arrow indicates which kind of process is going on. So the arrow here for the CMDevel shows that the avoid wall is publishing streams of data to TurtleSim, while this other one shows that it's actually subscribing the position and orientation from the TurtleSim. So there are a bunch of things you can do here. For instance, we can decide to go to the top here and choose nodes topics all. So it's going to show you more information this manner. You can also choose just this one, which is basically going to show you the same thing. And then, so in this case, it's kind of grouping it in another way. You have the nodes by this side, this TurtleSim and avoid wall, and then you have the topic. So the turtle1 pose is a topic, and that topic is publishing the position and orientation to the avoid wall. Okay, you have the CMDevel also. All right, so let's move on to the next thing. The next thing here is the plugin under the visualization called plots. So I'm going to cancel this right now. Now this plot, of course, actually plots graph. So you can decide to, let's say we have the linear velocity in X direction, the X and Y, and we want to plot the graph of the linear velocity or even the position and orientation of the turtle. So let's try the pose, for instance. Remember, for the pose, you just have to go in here where it says topic, and then you type in the name of the topic responsible for that kind of message. Okay, so we have the pose, and then we're not done. Now, if you have the pose, you add your /, and then immediately you add the /, you will see that the plus sign here becomes active. Now, when the plus sign becomes active, you can just click on it, and then you can see it's plotting everything on the Turtle One CMD, Turtle One pose. Okay, you can go down here to choose the one you don't want. You can see because I've already run some stuffs before, I have CMDevel also there, and you can decide to remove it. So the minus is for removing. So you can remove a particular, let's call it variable. You can see I'm trying to remove all the CMDevel, and then we have this one here right now. Okay, so this is how you plot the graph, and the graphs you can see it's color coded. The Turtle One post X is color green, and the other ones have their own color. So with that, you can always plot, the graph of your robot or your turtle, or anything you have in your ROS program. Okay, so there's another tool which we can't use right now because we do not have a camera. But if you have a camera node, you can use the image view. So the image view is when you have a camera node, and then the camera node is, at this point. So with the camera node, you can always see the feedback that you're getting from your camera. Whatever your camera is showing you from your robot or from your simulation, you can always, see it from this point. Okay, so this is RQt, and that's all about RQt. See you next time in the next lesson.